Let us look at sensitivity analysis and margin of safety with reference to cost volume profit analysis. So let's first look at the sensitivity analysis. So sensitivity analysis is a what if technique. So what if technique used by managers to assess the impact on the results, such as operating income, if the originally predicted data is not achieved. Example could be number of units sold, or if an underlying assumption changes. So sensitivity analysis is a what if technique used by managers to assess the impact on the results if the originally predicted data is not achieved or if an underlying assumption changes. So if I put it in very simple terms, in any kind of processing, you have input which undergoes a process and generates an output. So here in sensitivity analysis, we are trying to find out what will be the change in this output if this input changes. So in the context of cost volume profit analysis, sensitivity analysis can help us answer questions such as what will be the operating income if the units sold decreases by 15% from the original prediction? What will be the operating income if the units sold decreases by 15% from the original prediction. Or it can also be something like what will be the operating income if the variable cost per unit increases by 10%? So what will be the operating income if the variable cost per unit increases by 10%. So this type of analysis helps the manager in analyzing the various possibilities before they make any cost commitments. So let us look at this table being prepared by a manager who is performing a sensitivity analysis. So the fixed cost is being estimated as $2,000. There are three possible variable costs: $100, $120, or $140. So all these are in terms of dollars. Now the manager is trying to find out the revenue required at a selling price of $200 per unit in order to earn an operating income of $0, $1,000, $1,500, and $2,000. So basically, the manager has set different levels of targeted operating income and is now trying to find out how much revenue should the company make in order to achieve those operating income. Now another variable that the manager has put is that if the variable cost is 100 or 120 or $140, then how much is the revenue required at a selling price of $200 in order to earn an operating income of $0, $1,000, $1,500, and $2,000. So the first case is that the fixed cost is $2,000 and variable cost is $100. The targeted operating income is $0, that means break even, and the selling price is $200. So how much should be the revenue? So let me do a quick calculation here just for this one. So the profit is 0, and we know that the profit is equal to the total revenue minus the total cost. So total revenue is Q, which is the quantity, multiplied by the unit selling price, minus the total cost. The total cost is addition of fixed cost and the variable cost. So fixed cost minus the variable cost, and variable cost is the multiplication of the quantity and the unit variable cost. So 0 is equal to Q is unknown, so Q multiplied by P, which is 200, minus F is 2000, minus Q is unknown, multiplied by C, which is 100, or 0 is equal to 200Q minus 100Q is 100Q minus 2000, or if we bring Q on one side and 2000 on the other side, Q is equal to 2000 divided by 100, which is equal to, so these two zeros get cancelled, 20. So the quantity required is 20 units, and the revenue will be quantity multiplied by the unit selling price, which is 200. So 20 multiplied by 200 is $4,000. So the revenue required in order to break even at a variable cost of $100, fixed cost of $2,000, and selling price of $200 is $4,000. So we'll note 4,000 here. Similarly, for the other targeted operating income at variable cost of $100, the revenue required is 6,000, 7,000, and 8,000. Again, all these are in dollar terms. Now, what if the variable cost changes to $120? In that case, the revenue required is $5,000, $7,500, $8,750, and $10,000. Again, if the variable cost per unit is $140, in that case the revenue required will be 6667, $10,000, $11,667, and $13,333. So this kind of analysis before making decisions helps the manager analyze the situation better. Now let's look at the concept of margin of safety. Now, margin of safety is an aspect of sensitivity analysis. So this is an aspect of sensitivity analysis, which is the amount of budgeted revenue over and above the break-even revenue. Amount of budgeted revenue over and above the break-even revenue. And in terms of number of units, it is the sales quantity minus the break-even quantity. Let us understand margin of safety using the graph for break-even point analysis. So this is the x-axis, which has the units sold, and this is the y-axis, which has the dollar amounts. Let's say this is 2,000, 4,000, 6,000, 8,000, and so on. And these are 100, 200, 300, 400, 500, and so on. Now, let's say the fixed cost is $2,000. So let's draw the fixed cost line. This is parallel to the x-axis and represents the fixed cost. Now let's draw the total cost line. So that will start from the point where fixed cost merges with the y-axis. So let's say this line represents the total cost. Now let's draw the line for total revenue. So let's say this line here represents the total revenue. So the point where the total revenue merges with the total cost is the point of no profit and no loss, and we know that this point gives us the break-even quantity. So this is the point which is representative the break-even point. So let's say this is 150 units, and if we draw a line parallel to the x-axis, we'll get the dollar amount for the break-even point. Now let's say the company continues to produce more and at the end of the year produces an amount of 300 units. So this point here, if we draw a line parallel to the x-axis, will represent the dollar amount for the total revenue, and if we draw a line parallel to the x-axis from this point on the total cost line, then this point will represent the total cost. So this is the sales quantity and this is the break-even quantity. So the difference between the two, that is this difference here, represents the margin of safety. That means that this company has a margin of 150 units before it slides down into this area, which is the area indicating loss. So anything to the right of this break-even point indicates profit, anything on the left of this break-even point indicates loss. So the more right hand side the company is, the more safety margin and lesser chance of sliding into a situation of loss. So as discussed, the margin of safety helps in answering the following what if question. If we have budgeted the revenues for next year to be at a level above the break-even point, and if in actual that level of revenue is not achieved, how far can it drop before the break-even point is hit? Now, these kind of falls could be a result of a competitor launching a better product or a poorly executed marketing plan by the manager's company.